All right, so today we're looking at how to draw a cubic function. So we have been given a cubic function which has already been factorized for us, which is f of x equals x minus 1, x plus 2, x plus 4. These are the three linear factors of our cubic function. So we can re-expand this function so that we get to see the true form of this cubic equation. So first thing, let's expand these factors so that we see our true cubic equation. So we'll expand the brackets, we multiply each of the brackets. We're going to start x times, we multiply first x minus 1, we multiply by x plus 2. We're going to start x times x, we're going to get x squared. X times 2, we're going to get 2x. Negative 1 times x, you get negative 1x. Negative 1 times 2, you're going to get negative 2. You simplify this, so I'm going to say x squared plus 2x minus x, we get x minus 2. Then finally, we're going to multiply it by x plus 4. So we're going to start x times x squared, get x cubed. Then we go, so I'm going to put x cubed here. X times x, we get x squared. So say x cubed plus x squared. And x times negative 2, we get negative 2x. And I'm going to say 4 times x squared, we get 4x squared. 4 times x, we get 4x. And then 4 times negative 2, we get negative 8. So it's just a matter of grouping like terms together. So we've got an x squared here. So say x squared plus 4x squared, you get 5x squared. X cubed is by itself, so we just write it here. X cubed plus 5x squared. Okay, we've got negative 2x here plus 4x. We're going to get positive 2x minus 8. All right, so this is our cubic function. A cubic function is a function with the highest degree, which is 3. The highest degree is the power of 3. And as you can see here, we had 3 factors. So now we're going to see how we can make a sketch of this graph. So the first step, we have to consider the sign of the leading coefficient so that we can have an idea of the way our graph is going to look. So I'll say step 1, consider a. A just represents the coefficient of x cubed. So in this case here, our a, which is the coefficient of x cubed, is 1, and it's a positive, and it's greater than 0. So if your leading coefficient is greater than 0, your graph is going to look, this is the rough sketch of your graph. Your graph is going to look something like this. All right. It is going to start concave down, then switch and become concave upwards. All right. So we have an idea how the graph is going to look. Step 2. Hello, Sibongile. All right. We are looking at how to draw a cubic function. Right. So we're dealing with this cubic function, which is here. So we are on step 1, where you have to consider the leading coefficient, which is denoted as a, so that you can have an overall idea of how your sketch will look like. So in this case here, our leading coefficient is 1, and it's greater than 0. So our function is going to look like this. So we've got a rough idea of how the function is going to look. So we're now heading into step 2, where you have to determine the y-intercept. So in order to get your y-intercept, just set x equal to 0. Or another trick you can use, you just look at the number without a variable. So in this case, so in this case here, this -8 is our y-intercept. But you have to do it formally, so you're going to substitute x for 0 in the original function. So get your piece of paper and substitute x into the function. Let me know if you get -8. Okay, have we both got -8? So our y-intercept is going to be 8. So the coordinates of the point where this graph is going to cut the y-axis is going to be 0 and -8. Any questions? Okay, we go to step 3 where you have to get the x-intercepts. Now, the good thing for you guys is you're not doing add math, so usually this is the time where you have to factorize the cubic function so that you get the linear factors and then you solve for x. But for us, we already started the question with the linear factors of this cubic function. So these linear factors, x minus 1, x plus 2, x plus 4, you equate all of them to 0. And then you get the values of x. So we say x minus 1 equals 0. X, is it x plus 2? X plus 2 equals 0 and x plus 4 equals 0. And x plus 4 equals 0. So our x-intercepts are going to be 1, -2, and -4. So these values, okay, in your spare time, you can substitute them back into the original function. What you notice, you'll be getting 0. Each time you substitute 1 into this original function, you get 0. -2 in this function, you get 0. -4, you get 0, right? So the coordinates for the x-intercepts are going to be 1 and 0, -2 and 0, -4 and 0. Are we okay with step 3, finding the x-intercepts? Any questions? All right, step 4 now, you have to find the stationary points. Now, this is where the calculus comes in. Remember, stationary points, these are the points where the gradient equals to 0. Right? So you need, for step 4, you need to derive the cubic function. So it says stationary points here. So the way we're going to derive this function, we're going to use the power rule. All right, let me just write down the power rule here. All right, with the power rule, what happens is if you have an exponent, oh, sorry, let me read like this. If you have a coefficient and a variable, let's say with an exponent to the power n, what's going to happen is the exponent, you're going to multiply it with the coefficient. Then after you multiply the exponent with the coefficient, you subtract 1 from the exponent. So let me just show a small illustration. For example, if you have 2x to the power 3, you're going to multiply the exponent with the coefficient 3 times 2, you get 6. Then you subtract 1 from the exponent, 3 minus 2, and 3 minus 1, that is 2. So you get 6x squared. That's the principle that we're going to use to differentiate our cubic function. So when we differentiate our cubic function, we're going to get a quadratic function. So let me write the function, then I differentiate it. X cubed, let me just write it down. X cubed plus 5x squared plus 2x minus 8. We have x cubed plus 5x squared plus 2x minus 8. So we're going to derive this function. So as I said, so x cubed, our coefficient is 1 here, all right? So you multiply the exponent, so you're going to say 3 times 1, you're going to get 3. Then you subtract 1 from the exponent, so you're going to end with 3x squared. So now you have a quadratic function. We derive the next one. You're going to multiply the exponent 2 times the coefficient 2 times 5, that is 10. Then you subtract 1 from the exponent. So you're going to get 10x plus, what, 2x to the power 1. So you said the exponent 1 times 2, you get 2. Then you subtract 1 from here. 1 minus 1, that is 0. So x to the power 0. Remember from indices, the law of indices, anything to the power 0 is 1. So x to the power 0 is 1. So you just leave it as 2 there. Then numbers that don't have any variables, they disappear. Okay, so this negative 8 has gone, disappeared into thin air. Yes. Any questions? Well, well, wait. Let me just understand your question. You're saying where are we finding what? Oh, it's the question. The question started like this. It started with the factors. You're given a function with the factors. All right. So now we expanded this so that we get a cubic function. All right. This cubic function, when it's factorized, it becomes these 3 factors here. So we expanded these 3 factors to get our cubic function. So that, because with this type of questions, you would want to be using the cubic function in its ordinary state. There is a need because the question is sketch the graph. So here we're just getting all the important points on the graph so that we can make a sketch. Yes, so just now once you've derived the cubic function and you've got your quadratic function. Okay, graphically what we have done is this, right? This function is like this. Now when we derive it, it becomes a quadratic function. It's changed from this S looking shape to a U looking shape. All right. Actually, since this one is actually positive, so like this, it's become like that. We've changed this graph into a quadratic function. Now, if you remember what I said last time, the intercepts or the roots of a quadratic function, they will be at the same position as the stationary points for the cubic function. That's if this quadratic function has got real roots. If you get a root like, let's say, negative square root of 3, that's not a real root. Okay. But the answers the values of x that we're going to get from this quadratic function are going to be at the same point as the stationary points for the cubic function. So we equate this to 0. This equation doesn't look like it can be factorized, so we can use the quadratic formula so that we can get our roots. So before we put our quadratic formula, we list down our a, which is the coefficient of x squared. It's 3. B, the coefficient of x, 10. C, the constant, which is just 2. So the quadratic equation, negative b plus minus b squared minus 4ac over 2a. So we just substitute. So our b is 10, so we say negative 10 plus or minus 10 squared minus 4 times 3 times 2 divided by 2a. 10 squared, that is 100. 4 times 3, 12. 12 times 2, 24. divided by 2 times 3, which is 6. Okay, I will need help with your calculators because I think this one, which is coming in the square root, will be a funny number. 100 minus 24, that should be, what do we get? Is it 76, if I'm not mistaken? Yeah, it's 76 over 6. All right, so remember, for a quadratic equation, it's always got two roots, two x-intercepts. All right, so you have two values for x. So you're going to say negative 10 plus the square root of 76 divided by 6. And then you have negative 10 minus the square root of 76 divided by 6. So with your calculators, what is the square root of 76? Just give me to one decimal place. Give me the answer to one decimal place. What's the square root of 76? Okay, 8.7. So, excuse me, negative 10 plus 8.7 divided by 6. Do not worry, in your tests, if they bring such questions, you you'll be able to find x is equal to 2, x is equal to 3 whole numbers. Unless the teacher wants you to suffer, then he'll bring this type. All right, then we have negative 10 minus 8.7 divided by 6. Okay, so negative 10 plus 8.7 divided by 6, I need both values to one decimal place. Are you both there? Yes, the value of x. I need both values of x. Negative 8.5. Okay. Just not, you're supposed to find negative 0.2, because negative 10 plus 8.7, you get negative 1.3. Negative 1.3 divided by 6, negative 0.2. Then you said the second one you got 11. Okay, let me just confirm. Negative 3.1. Try recalculating so that you get these values. And Swongile, have you also got these values? Remember, do this operation on top first, then divide. Even this one, operation on top, divide. And before I go further, are there any questions? These are the x coordinates of, okay, these are the x coordinates of the stationary points. Now, to find the y coordinates of the stationary points, we need to substitute these two values back into the original cubic function so that we get the y coordinates for these stationary points. Let me just write it down so I don't forget. X cubed plus 5x squared plus 2x minus 8. So we substitute both x values into this function so that we get our y coordinates for the stationary points. So first let's substitute negative 0.2, negative 0.2 here. So remember here we're trying to get the y coordinates for our stationary points. Get our calculators. Negative 0.2 cubed plus 5 times negative 0.2 squared plus negative 0.4 minus 8. So you get negative 8.2. I hope you both tried this. I hope you're both getting this value. So you say negative. So the first coordinate is negative 0.2, negative 8.2. Next, we substitute negative 3.1. All right, so start negative 3.1 cubed plus 5 times negative 3.1 squared plus 2 times negative, that's negative 6.2 minus 8, you get 4.059, so we can just round it off as 4. So negative 3.1 and 4. Okay, so these are the coordinates of the stationary points, right? Remember, first we got the coordinates of the y-intercept, coordinates of x-intercept. Now we've got the coordinates of the stationary point. Then finally, the final step is to find the inflection point. It's where the graph changes concavity. So in order to get the inflection point, we need to derive, get the second derivative of the cubic function, meaning that quadratic function that we got, we need to derive it. All right? We need to derive it. And this will represent the second derivative of the cubic function. So the quadratic equation 3x squared plus 10x plus 2. Can both of you try to derive it? Remember, it's you multiply the index or the exponent multiplied with the coefficient. So we have 3x squared plus 10x plus 2. Okay, has anyone tried to derive it? It's quiet. I'm getting scared. When both of you are quiet, I get scared. Sibongile, have you tried to derive this? Fiona, have you tried to derive this? Or maybe I derive it, then we compare. If you get the answer, say, oh, sir, I got that answer. Someone was about to say something. Yes, proceed with what you're about to say. Multiply the exponent with the coefficient. 2 times 3, that is 6. Subtract 1 from the exponent, you remain with 6x to the power 1. Okay. Multiply the exponent, x to the power 1. So 1 times 10, that is 10, minus 1. X to the power 0 is 1. So this is our second derivative. So what has just happened here is the quadratic function, which was like this, has now changed into a line. Okay. It has now changed to a line. If you remember from coordinate geometry, y equals mx plus c, we have the equation of a line here. So now we need to equate this to 0 so that we find our x coordinate of the inflection point. Oh, did any of you get 6x plus 10? Do not worry, if you got it wrong, it's okay to get things wrong. Okay? That's how you will learn. But if you're scared to get things wrong, school will be hard. Okay? The numbers without variables, they go. And the good thing about it is you don't need to show how it goes. But I can explain to you how it disappears. Okay? These two, it's like 2 times x to the power 0. So 0 times 2, that is 0. 0 minus 1, that is x to the power negative 1. If you remember from indices, anything to the power negative 1, you bring it down. So it's like 0 divided by x. 0 divided by x, 0. Okay? So that's how the numbers without a variable disappear. Okay? In your workings, you do not need to show this. Okay? You do not need to show that. You just show the new answer. All right, so let's see. We have to solve for x. So we say 6x. We take 10 over the other side, becomes negative 10 divided by 6. So we're going to say x equals, so negative 10 divided by x to one decimal place, negative 1.6 or 1.7, negative 1.7. So this is the x coordinate of our inflection point. In order to get the y coordinate, we need to substitute x for negative 1.7 into the original function. So we have negative 1.7 cubed plus 5, open brackets, negative 1.7 squared plus 2 times negative 1.7 minus 8. Okay, so we've taken this and put it into the original function. So let's solve for our y coordinate. So we say negative 1.7 cubed plus 5 times negative 1.7 squared plus 2 times negative 1.7 minus 8, negative 1.8. So the coordinates for our inflection point are negative 1.7 and negative 1.8. Any questions? So we've got all the important points that, so we can sketch this graph. Okay, we can sketch this graph. Now, it's not all the times questions will come like this. They maybe ask you just find the inflection and the stationary points, maybe just find the x-intercepts, y-intercepts. But this question is showing you everything that has to do with cubic functions. Okay, so first things first, let's make a sketch now of this cubic a function on this cubic graph. Okay, we need first the coordinates for our y-intercept 0, -8. So let me just draw a graph here. 0, -8. So it should be somewhere here. Okay, it's not to scale. So if it looks funny, just remember it wasn't to scale. So yeah, what was it? 0, -8. That's our y intercept. Next, we need our x-intercepts, 1, 0. So 1, 0 is somewhere here. -2, 0. And -4, 0. Next, we get our stationary points. Down -0.2, -8.2, and we have what's the other one? -3.1 and 4. So let's see, -0.2, -8.2. So -0.2 should be somewhere here. And then -8.2. So maybe we would say it's somewhere here. All right. Then the other one was -3.14. So -3.1 should be somewhere here. We estimate this is like a 3, so 3.1 should be somewhere here, and 4 should be somewhere here. Then our inflection point, -1.7, -1.8. Right, -1.7, -1.8, somewhere, we'll say somewhere here. So this is where the concavity changes. So -1.7, -1.8. Okay, so it's now time to connect the dots. Oh, then it cuts the y-axis. So at this point here, the concavity changes. So let's make it orange here. The concavity changes here. Then it cuts the y-axis, then goes up again and cuts the x-axis. Oh, wait. I've forgotten one point. There's this point here, our other stationary point. It will first hit the stationary point, then cut the y-axis, and then yes, go like this. So this is just a rough sketch of the graph. But yeah, so this is our graph. It's negative 0.2, negative 8.2. Yes. So a recap of what we've done. When you're about to sketch this graph, step one, consider the leading coefficient, which is a. If it's positive, as we can see, we already predicted that our graph will look like this. And you can see our graph starts concave down, then goes concave up. Step two, you need to determine the y-intercept, where the graph cuts the y-axis, which is here, at this point here, negative 0, negative 8. All right. Step three, you need to determine the x-intercepts, which are here, 1, where the graph cuts the x-axis. Oh, so this one was supposed to go like this. Okay, it's not to scale, so please don't laugh at how it looks. It's just not to scale. Yes, the 3 points where it cuts the x-axis, the x-intercepts. Right. Step four, we have to find the stationary points. Here, one, and here the other one here. Step five, we have to find the inflection point where the graph changes concavity, which was here. Okay, so once you have the points, just connect the dots. All right. Yes. Any questions? Who is presenting this on Sunday? From step one to step five? Hmm? So I never heard.